Hello, and welcome to today's webinar, Moving Your File Data to Amazon EFS. On your screen, you will see a Q&A pod. Please submit your questions for our presenters and moderators at any time, and we'll address them as they come in. At the conclusion of today's presentation, there will be several poll questions preceding the live Q&A. Please provide us with your feedback when you see these poll questions appear on your screen. Today's webinar is being recorded. In the next few days, we will send you a follow-up email with the on-demand links to the presentation deck and webinar recording. And again, welcome to today's webinar, Moving Your File Data to Amazon EFS. Today are Daryl Osborne and Prash Bungale, Solutions Architect with AWS, and Prash is one of our product managers within the EFS team. Today with us, we also have Andy, Srini, and Anil. They are our team of moderators today and will be engaging with you in the Q&A pod, answering your questions throughout the presentation. Welcome, Prash.
Thanks so much, Joe. Again, as Joe mentioned, my name is Prashant Bangale, and I'm a product manager for Amazon EFS. Daryl and I are excited to be doing this webinar for talking about moving your file data to Amazon EFS. For the agenda for today, we'll go over what Amazon EFS is and talk about some of the features of this and some of the availability and other characteristics of EFS. We'll also then talk about how you can ingest your data. That will be the focus of the session. And then we'll wrap up with some demos and some Q&A as well. So first, let's talk about what Amazon EFS is and all of the features it provides. So before we talk about EFS in particular, let's talk about if you wanted to do your own file storage, if you wanted to implement that solution yourself, how would you do it? So prior to EFS, you would have had to provision individual file server instances, the EC2 instances that would serve as your file server, for example, running an NFS server. And then you would have to provision your individual EBS volumes that actually store the underlying data onto these EC2 instances, install and configure the software, and make sure everything is working right. And then in addition to these things, you would probably provision an additional file server in another availability zone in order to provide higher availability. And then also you might want to provision additional storage volumes and configure replication across these storage volumes, across availability zones, in order to ensure higher availability and durability. And then you would have to figure out how the failover itself works, how the clients can actually talk to the appropriate file server, whether it's the primary or the secondary. And so overall, as you can see, there's a whole lot of effort involved in setting up, configuring, and managing the overall file server setup. So we introduced Amazon EFS, which is a fully managed file service. And specifically what it provides is a lot of benefits for you in terms of running a fully managed file service. So let's talk about those benefits one by one. So Amazon EFS is simple. What we mean by this is the interface that EFS provides is basically the standard NFS version 4.0 and version 4.1 protocol interface. And you can use your existing applications that rely on a file interface as well as file system semantics to work seamlessly with EFS without the need to re-architect your applications or change anything drastically. Another aspect of EFS's simplicity is basically the fact that you don't have to worry about the setup, configuration, and management. EFS takes care of all of those overheads for you. Is elastic, and what we mean by this is the storage itself actually grows and shrinks as your file system changes in terms of its data. So as you add data, the EFS storage, underlying storage, basically changes elastically to accommodate your storage changes. EFS is also elastic in the sense of throughput. So it actually provides scalable throughput performance for your file systems. What we mean by this is your applications can actually drive higher and higher amounts of throughput as your file system grows in size. So the model that EFS provides is you get a certain amount of throughput per unit of storage. For example, you get 50 megabytes per second of throughput per terabyte of storage. And also EFS has a bursting model to simplify this even further to actually allow your applications to burst to higher levels of throughput for short amounts of time, characteristic of file-based workloads. And lastly, but importantly, EFS also is highly available and durable. What we mean by this is your data in your file system, every object in your file system, be it a file or a directory or metadata itself, is actually stored across multiple availability zones. And EFS also provides you multiple, what we call mount targets, for your clients, for your actual applications to be able to access the file system from multiple availability zones. So this provides for a highly reliable, highly available and durable, simple, elastic, and scalable file system that you can spin up in a matter of minutes using the AWS Management Console or using the API or CLI. EFS is designed for a wide variety of workloads. It really is designed to serve a wide spectrum of needs, whether it's in terms of high throughput and parallel I/O needs on the one side of the spectrum for applications like big data analytics and media workflows and so on, or it's the other end of the spectrum where the application needs are around low latencies and serial I/O operations that applications perform. So examples of applications at that end of the spectrum are developer tooling, home directories, container storage. And then in the middle of the spectrum, you have all kinds of applications, everything from one of our most popular use cases, which is web serving, all the way to content management and database backups and enterprise applications, messaging, and so on. So the way EFS is able to offer performance that is suitable for this wide spectrum of applications is basically by providing two different performance modes. One called the general purpose performance mode and another called the max I/O performance mode. The general purpose performance mode is really the default performance mode that EFS provides, and that is expected to be the right mode for the vast majority of the applications out there. Then the max I/O performance mode helps you drive higher amounts of throughput and IOPS on your file system with the trade-off of slightly higher per operation latencies, because those are not what matter for highly scale-out applications. Here's a list of customers in each of these use cases that I talked about just now in terms of customers that are using Amazon EFS for their workloads today. Long list, and there's also a list of references and case studies on our website. I'd highly encourage you to go through those if you're interested to learn more about a use case that matters to you. In terms of the security model, EFS actually offers security at various levels. So let's start at the network level. So at the network traffic level, EFS actually allows you to control exactly what traffic is allowed to go through in terms of your Amazon VPC security groups and network access control lists. So by using configurations related to Amazon VPC security groups and network ACLs, you can actually control exactly what EC2 instances are able to talk to your EFS file systems and which ones should not be able to. You can actually control individual file and directory level access by using POSIX permissions, by using the standard Unix file system permissions that you're used to, that your applications are used to over the last decades. You can also control administrative access in terms of being able to use the API versus not, using the AWS Identity and Access Management action level and resource level permissions with IAM in terms of being able to control this kind of access. And finally, EFS allows you to encrypt your data at rest by using keys managed in the AWS Key Management Service. And here, all the data and metadata in your file system are encrypted, automatically. They are encrypted before access and decrypted before access and encrypted after writes and so on, automatically without any need for involvement in terms of the actual application or any re-architecting for the application itself. In terms of access choices for EFS, EFS actually supports various options in terms of the environments themselves. So you can actually access EFS file systems from your applications running on Amazon EC2 instances. You can also access EFS from your on-prem data center using Direct Connect, for example. And you can also access EFS file systems from the VMware Cloud on AWS. Let's talk a little bit about EFS economics now. As I mentioned earlier, EFS is that elastically grows and shrinks your file system as your data needs change. So there's no minimum commitment that you're making upfront. There's no need to provision the amount of storage in advance. There's no fees or charges or other billing dimensions that you would need to worry about. So all you pay is a flat per storage unit price, which is shown here for the various regions that we are available in. One way to think about the economics itself is if you go back to the very first slide that I started with, which is the do-it-yourself file storage solution, the dimensions you would have to think about in terms of your costs are basically the EC2 instances themselves, provisioning your file servers, the storage volumes, the Amazon EBS volumes that you would need to attach behind these file servers, and the transfer costs in order to actually enable the replication, the synchronous replication across multiple availability zones to ensure high durability and availability. If you consider all of these costs and add them up, it basically turns out that for an example where you're storing 500 gigabytes of data on Amazon EFS, you would actually see that it's about 70% less than the do-it-yourself solution, where you would have to pay for the various components of storage and compute and inter-AZ data transfer. So it shows you how compelling Amazon EFS would be because of the power of the simple, elastic model that it presents and the pricing model that it presents. In terms of Amazon EFS's availability, we are available in 6 regions today, as shown here, and we have availability of EFS in more regions coming soon. So at this point, I'd like to pass it over to Daryl, who will take us through ingest and also give us some interesting demos.
Great. Thanks, Prash. Appreciate it. So when we think about ingesting data into AWS, it's important to know about the resources available to you. Amazon EFS is just one of the building blocks at AWS. Storage, we typically think about the storage type. Different storage types offer different interfaces, semantics, permissions models. System, data is stored as files in a directory hierarchy, and there is a particular metadata associated with each file. So in other words, the data is stored natively in a file system format. For this, we provide Amazon EFS to satisfy your file system needs. A disk or a set of disks are attached to a single computer, and the data is stored in chunks called blocks. Will work with this block storage and present data in a file system format while storing the raw data as blocks. So you can think of this as locally attached storage or locally attached disks. Provide Amazon EBS. And then with object is just data stored in a container called an object, and each object is identified by a unique key. Objects are stored in a flat space. There is no hierarchical structure. Object storage, and we provide a simple API to get and put data based on this key. This is commonly accessed over the internet. And for this storage type, we have Amazon S3 and Amazon Glacier. So these core storage services are a number of data movement tools and data movement services, as well as some data security and management services. What do you think about, though, when you need to ingest or move data into EFS? Well, first, the source. Where is it coming from? And second, the mechanism. How do you copy, move, or transfer this data fast and efficiently? We can generally describe where it's coming from into 4 categories. First, on-prem. Typically, this is from a corporate data center. Second, typically this is coming from Amazon EBS, from an existing file system. And third, another cloud service or maybe a software appliance. Or fourth, from Amazon S3. When coming from on-prem, typically, this is a corporate data center, you have a few options. First, can mount an EFS file system via a AWS Direct Connect connection. So this Direct Connect provides a high bandwidth and lower latency dedicated network connection over which you can mount your EFS file system. Once you have this Direct Connect connection established, you can mount your file system from on-prem servers and use your standard Linux copy tools to copy, move, or transfer files to EFS. Now, if you don't have an AWS Direct Connect, you can still securely copy, move, or transfer files from on-prem servers to EFS, using a third-party VPN solution. Now, there are a number of third-party VPN solutions available. Some of them are open source, and some of them are even in the AWS marketplace. You may think that these types of connections that I just talked about are just for migrating files to Amazon EFS. Well, besides migrating data sets permanently to EFS, these connections can also be used to burst into the cloud temporarily. Moving a data set temporarily into EFS, then accessing this data from applications running on EC2. Once your application has processed this data, you can move it back to on-prem. You can also use it for backup and disaster recovery scenarios. So a few weeks ago, we released EFS File Sync. So EFS File Sync provides a simple, fully managed solution to transfer files into Amazon EFS using secure, high-performance parallel data transfer. EFS File Sync provides encryption the environment to AWS and throughput that is up to 5 times that of standard copy tools, and an end-to-end management process using the AWS Management Console. This is a simple, fast, secure tool to migrate data into EFS from on-prem or even within AWS. So let's go ahead and spend some time now and actually do a hands-on demo of EFS File Sync. So here within the Management Console, we want to get to EFS. So there's a number of ways to do that. We can look down here and click on EFS. You can also type EFS here in the search. I like to do is actually pin it up here at the top. So I don't know if some of you know this. If you click on this pin, you can go down to EFS, drag it up here, and now it's always going to be there. It makes it very easy to get to EFS. In the EFS Management Console, we access EFS File Sync via the File Syncs link. First thing we need to do is we need to deploy an agent. So if we're going to be migrating from on-prem, we would click on Agents, create a sync agent, and then if you would download the ESXi image, then deploy that in your environment. If you're going to be migrating from AWS, you could deploy the EC2 AMI of the File Sync agent into any of the regions just via this easy wizard. Deploy this now. I already have an agent set up. So once you have your agent running either on-prem or within AWS, you would create a task. Now, you come back to the File Sync Management Console, click on Create a Sync Task, and here you would identify your source. So this example that I'm going to walk through, I'm going to copy from or migrate from one EFS file system So what I would want to do here is identify the NFS server IP address or the domain name. So in this example, I'm just going to be copying from an existing EFS file system. So I'm going to grab the DNS name of that file system and just paste it in here. I'm going to be coming from the tutorial directory, and I would select the agent that I've already deployed. This is an EC2 instance within my environment. Configure the destination. And here I would select an EFS file system that's going to be the destination of this sync. And in this example, I'm going to go ahead and select this general purpose file system that I have set up. The root path of this file system, and select the security group that will gain access to this file system. Click on Next to go into the configuration settings. Here I can identify the ownership permissions or timestamps that I want to copy as a part of the metadata for my files. I can also identify if I want to keep the files in the destination, even if they're not found in the source. And I can check on this verification mode too, to have full consistency between my source and destination. Next, give it a very simple name, and then go ahead and create that file system. I have one set up, so I'm going to go ahead and cancel this, and I'll just show you how easy it is to get going. It does take a few minutes for the task process to be created. I'm not going to walk through that process, but I already have one set up here where once the sync set is created, we would select it in the management console and start. It's really that simple. If I wanted to change any of the attributes of my sync set, I could do that here and start. After a few seconds, you'll see the status changing from start to actually progressing, and this will progress through the entire process of migrating my data set from my source to my destination. It's really that simple. No need to SSH into the source or destination instances to copy that data. This is securely being transferred from the source to the destination, all to the management console. So very easy, very fast, migrate data into EFS from either on-prem or from within AWS. So let's go back to the slides. I want to show you a couple other use cases and examples that to ingest data into AWS. So we'll stop sharing and we'll go back to the slides. Here we go. So another use case we talked about was migrating data or moving data from Amazon S3 to Amazon EFS. So when you mount an EFS file system, one thing we recommend is that you use Linux kernel 4 and above and mount using NFS client 4.1. Use the default mount options for most of the modern kernels out there. Recommend that you use your file system DNS name, which is created and provided to you when you create your file system. Data from S3 to EFS, you mount the file system on that EC2 instance using NFS client 4.1, and then you use your standard S3 tools to copy objects from S3 over to EFS. Find though that you want to continue to use parallel or multi-threaded transfer techniques when migrating the data. So you want to have multiple threads and copying that data over to Amazon EFS. So let's demo. And we'll actually do a very quick hands-on demo of copying some objects that I have in an S3 bucket over to my EFS file system. Over to my terminal window. See that I've already logged into one of my EC2 instances. It's the exact same instance on the top and the bottom frames. First thing I want to do is actually just take a look at the EFS file system that's mounted to this instance. A df command, and I see that my file system is listed here. Can anyone very quickly do a calculation on how large it thinks this EFS file system is? 1K blocks here, very large number. We can easily find out what that is by doing a -H, and it actually sees this file system as an 8 exabyte file system. So again, a virtually unlimited amount of space you have mounted to this instance to move your data over. It really comes back to what Prash was talking about, the scalability and elasticity of EFS. So the first thing we want to do is, again, copy the data from S3 to EFS. So I've got some of my scripts listed here, and I'm going to identify and look at some of the objects. So I have 22 large objects sitting in this S3 bucket. These objects are LiDAR data. They're roughly a gigabyte in size each, and I want to copy them as fast as I can from S3 over to EFS. So what I want to do is take a look at my destination folders. I see that I don't have any data, or any files in the folders where I'm going to copy into. Basically, clear my buffer cache so that I don't have I don't have any data existing in my buffer. I'm starting out with a clean cache. Use the standard S3 CP command to copy the data over. I'm going to actually monitor this using nload. Nload is a network load utility. Visually in real time show you the incoming and outgoing performance, network performance of this EC2 instance. This will take a few minutes. So while we're waiting, Joe, are there any questions that have come in that maybe we can answer, I can answer, as we're waiting for this copy process to finish?
See here. Daryl, I think, yeah, there is a question here. There's a question asking, why are there gaps in the nload incoming and outgoing network display?
Yeah, so you see some of the gaps where you have little or no network activity going on. Well, when we're copying objects from S3, it is over the internet. There is higher latency involved in accessing objects over, using a web API. So there's going to be, gaps involved in this. So this is something we'll actually, you will experience when you're accessing objects over the internet. So if we're having a gap or lower throughput coming inbound, we're also going to have, some gaps going outbound over to our EFS file system because there's just no data to copy for that, millisecond or that second. So that's one of the reasons we have these gaps here or there.
I don't know how long this is going to take, but I do have another question if we have a minute.
Yeah, I think we have a couple minutes.
Okay, so this question is there any performance gain by copying objects through a VPC endpoint versus just copying them through a gateway and using the public endpoint?
Okay. So VPC endpoints really don't offer, throughput or latency benefits. So no, you're not going to see a benefit in terms of performance if you use a VPC endpoint for S3 or just going over an internet gateway accessing the public endpoint. Well, good. So as we see here, when we're this network throughput, the average, the average throughput we're seeing now and again, maybe around 60, 70. We'll finish up here in just in a few seconds, and we'll actually record the time of how long it took. So the data set is approximately 23 gigabytes in size. Copying data from the internet over to EFS, there's a lot of unknowns. It's somewhat inconsistent access, copying. It's the latency, the throughput may vary. That's really some of the reasons why we have some of these gaps, little or no incoming network activity during this test. finishing up here, we'll record how long it took. So it took 3 minutes and 24 seconds. So what is that? That's roughly, 204 seconds? Now let's go ahead and do another test. So in this next example, well, let's take a look at what it did copy over. So we'll do a quick test. We copied over 23 gigabytes of data to my directory. Now let's go ahead and do that copy, but this time we're going to use a tool called S3 Parallel combined with the S3 CP command. Again, we're going to flush our cache, and now we're copying objects from the same objects from S3 to EFS, but instead of using a S3 CP by itself, we're actually spinning up multiple jobs, and each job has a subset of the objects that we're copying, and we're going to be doing this in parallel. Now, S3 CP is a multi-threaded, but this, using it with new parallel, it just enhances the throughput, and you are able to run more threads than just using S3 CP natively. So as we can see here, we have a much higher throughput. Those gaps that we saw before aren't there anymore because we have, again, more threads accessing those objects. And even if one or two objects has maybe higher latency, where before we would see a gap in incoming throughput, we don't have that now because there's so many threads accessing those objects in parallel, and we have better efficiency and better throughput from S3 to EFS. Take a couple more seconds. Joe, any other questions coming in?
Actually, yeah, there is a question regarding new Parallel. Two questions. Where do I get more information on new Parallel, and how do I install it?
Okay, so yeah, at the end of the webinar, we will have a resources slide that will share a link to where you can get more information about new Parallel. And we also, if you're running Amazon Linux, the new Parallel has been added to the repository. So it's a simple yum install Parallel, yes, and bang, you've got new Parallel installed on your Amazon Linux instance. Up here, just a couple more seconds, and we're done. And take a look at the incoming. We see that we're done copying objects from S3, and now we're just finishing the write operations to EFS. And now we did that in 2 minutes and 10 seconds. So what is that, 130 seconds? So we see here, this is roughly, the incoming or the test where we ran just S3CP and by itself. We were getting a throughput of roughly 113 megabytes a second. We combined S3CP with new Parallel. We were able to do that in only 130 seconds of 178 megabytes per second. So really a 56% increase, or about 1.5 times faster. These large files from S3 to EFS when we combine S3CP and new Parallel. So that's great if you have large files, but what happens if you have some smaller files? So let's go ahead and do a test using some small files. Oh, and let's just go ahead and verify the size to make sure that we got all those files. So we take a look at this. This is the directory we are copying into, the S3CP plus Parallel. And again, we have those 22 files or objects now within our file system. Now what I have is I've got some objects in another bucket. And we'll go ahead and do a quick query. I've got 5,200 objects. These are small objects, roughly a megabyte in size. So we're going to be, a couple hundred kilobytes to a couple of megabytes each. And we're going to copy these 5,200 files or objects from S3 over to EFS. So the first thing we want to do is just verify that we don't have anything in the destination. We don't. And the first thing we're going to do is we're going to copy using our standard S3CP tools. Again, we're going to flush our cache, and we're going to start the copy process. So we see that, again, very efficient. We're seeing each object copy one at a time. If you take a look at the network load utility in the upper screen, we see that we're getting between 40 and 50 megabytes per second when using just S3CP when we're copying these objects over. This will just take a minute or two, hopefully. And actually, while we're waiting, Joe, any more questions?
Yeah, there is one question here. Can EFS File Sync copy objects from S3 to EFS?
So EFS File Sync, the source of an EFS File Sync can only be a NFS 3 or 4 data set. It doesn't work against an object store like Amazon S3. So no, you wouldn't be able to use EFS File Sync to copy objects from Amazon S3 over to EFS. So it looks like we're getting close here, probably the next couple of seconds. But again, I want you to look at the incoming and outgoing network traffic. So again, a lot more efficient because we have smaller files, and S3CP is multi-threaded. So we're trying to utilize as much network bandwidth. We don't have a lot of I/O waits happening. At least we have some type of activity incoming, coming into this instance, and then writing over to EFS. Again, our throughput is 40 to 50 megabytes per second. And we'll see that this may take close to maybe 2 minutes. So yeah, a minute and 51 seconds. And let's go ahead and see how, take a look at the files that we actually wrote. Grab this one. And we see that it actually did write the 5 gigs of data and 5,200 objects. Now, the next test we're going to do is just like the other one. We're going to use S3CP and new parallel to copy these 5,200 objects. So ask the question and it's a challenge. So we actually have a prize at the end. So what I want everyone to do is guess how long it will take to copy these 5,200 objects, which are 1 meg in the files, from S3 to EFS using S3CP and new parallel. And whoever is the first to guess how long it will take and is the closest to the time will actually win a prize. I'm not going to tell you what the prize is until the end. So go ahead now in your chat window, type in how long you think it's going to take to copy these 5,200 objects from S3 to EFS using S3CP and new parallel. So we're going to cut it off here in the next couple of seconds so there's no more answers coming in before we start. And let's go ahead and start that process. And boom. Look at this command. The first command, I'm actually going out and I'm taking a look at all of the objects, and I'm identifying the of some objects, and each prefix is going to get a different thread writing to EFS. So again, new parallel is able to take advantage of the distributed data design of S3 and EFS. And here we're going to get high levels of throughput. If you take a look at the coming and outgoing network levels, before with just S3CP by itself, we were getting 40 to 50 megabytes a second. Now we were getting what, close to 150 megabytes a second. We did that in only 41 seconds. So again, we went from 111 seconds to 41 seconds, or roughly 44 megabytes per second, to 121 megabytes a second. Increase of what, like 170%, and over 2.5 times faster using S3CP and new parallel versus just using S3CP by itself. So I know we're getting close to time. of slides left to share. So first thing, we saw that while S3CP is still a multi-threaded tool and it's good, a better solution is using S3CP and new parallel. You're going to really get the best throughput from S3 to EFS. These are some results that I had earlier in one of my tests. We already talked through some of those results during our demo. So this is for large files, and this one is for small files. To wrap up, first thing I want to do is we'll actually go through to find out who was the closest. We'll go ahead and we'll contact you, and we'll send you an echo being the closest to guessing how fast it actually will take to copy files or objects from S3 over to EFS using S3CP and new parallel. So just as a quick wrap up, again, when you're copying from on-prem or within the cloud from, say, EBS, we want you to use Amazon EFS File Sync. If you're copying from S3 to EFS, we want you to use S3CP and new parallel. You're going to take advantage of this distributed data design of both systems. And here are some of the resources that we have to you that you can review after the webinar.